he invented probabilistic latent semantic analysis, which is the idea that you can take a bunch of terms and looking at the core occurrence of these terms, you can learn topics that are behind them. It was also the assertion that every document consists of a set of probabilistic topics, which are mixed somehow. So we're getting beyond words, we're getting to topics in documents. And over here, this is Shiv Vaidyanathan, who worked at Almaden, which is the building over there. And he was more of a Bayesian guy. So he looked at, I'm going to do learning, but I also know things about the world ahead of time. I have these preconceptions. How can I encode those so the learning can take advantage of them? And he looked at how can you explore new data using a little bit of knowledge to find new patterns that you've never seen before. So machine learning was having a big resurgence, and Shiv and I used to argue about what machine learning was good for, because despite the fact he worked on machine learning, he said it never had a commercial success. And I would always say, well, there was like zip codes, or the US Post Office uses it for zip codes, I think. I don't know, I didn't have a good case at the time, but things that had been successful so far were statistical speech recognition, handwritten digit recognition, so this is zip code. So what happened was the USPS made this data set available of numbers that people had written on envelopes, and you try to identify the number. It's hard to do because handwriting differs. This over here, this is more recent, by the way, the cats versus dogs. There's actually, if you know what a CAPTCHA is, we have to type in the number that's all warped or whatever, the word that you can't read, and to test whether you're human when you're logging in somewhere. This is, Microsoft actually came up with this as another proposal that we're not going to make you type in these things. We're going to do something that's much more enjoyable. Just pick which one's the cat and which one's the dog. Identify whether it's a cat or a dog. That's really hard for computers. In 2006, 2008, the performance was still only 83% of cat versus dog. So it was getting 20% wrong. The human error is less than 0.5%. Now, as of you'll see. As of last year, they were up to 93% with computers. So that means the error rate's still 7%, which is much worse, almost 20 times worse than a human. So let's say you were going to classify cats versus dogs. And these are pictures. They're not the actual animal. What would you pick to classify? Like if you were going to tell a kid, here's how you tell the difference between a cat and a dog. From a picture, what would you tell them? What are the top 3 things? Well, you might talk about the face, you might talk about the ears, right? Like the ears are kind of pointy. The dogs are bigger, but it's a picture, right? So pictures are framed, so probably they're not bigger in pictures. Let me know if anyone thought of what one of the dominant features that every machine learning algorithm uses, which is dogs are green, cats are not.